Hey guys, we're going to be starting with section 1.5, which is infinite limits and limits on infinity. So before we get started, we're gonna give you guys the basic idea of what we're going to be looking at. So we're going to consider this function f of x is equal to 1 over x. So let's look at the limit as x approaches 0 from the left, meaning we're looking at numbers that are slightly smaller than 0. That's what this little plus sign means right here. It's slightly less than 0. So these are going to be very small negative numbers. So like negative 0.00001. So we're going to be looking at 1 over a very negative small number. So let's consider this when we have 1 over a very negative small number. So if I were to say we took 1 over negative 0.0001. So I'm going to show you guys in the calculator. So if we have 1 over negative 0.000001, so some very, very, very small negative number, a number close to 0 from the left side, we get a very large negative number. The smaller this number gets, we could have, oh, I forgot my point there, 0.0000001. Okay, so the smaller our number gets, the larger our number gets. This is negative 1 times 10 to the 18. So that's 18 zeros behind this negative 1. So this number gets very, very negative. So this actually, the limit for this one is actually a very, very big number, or a very negative, large number. You could call it large. It's the absolute value is very large. So the limit as 1 over x, or the limit as x goes to infinity from the left side of 1 over x is actually negative infinity. Because again, it's 1 over a very negative small number. Let's look at from the right-hand side. So again, the same idea, but this time we're looking at the right-hand side, so slightly more than 0, slightly larger than 0. So this is going to be 1 over a positive small number. So if we have 1 over a positive small number, so let's go back over here, 1 over 0.000001, we get a very large positive number. So this number actually goes towards infinity. The smaller the number gets, the larger the fraction will be. So let's look at infinity. So this is what we call, so these two, before we get there, these two are what we call infinite limits. So these are limits, limits as x goes to some number a, where the limit results in an infinite value. So this is infinite, these are infinite limits. These are infinite limits. They're numbers as x goes to some value a. We get our f of x value goes to positive or negative infinity. So these are infinite limits. We're going to look at limits at infinity. So now let's look at the limit as x goes to infinity, as x gets very, very, very large. So x is going to be some very large positive number. So 1 over some very large positive number, so very, very big number. And this is a positive large number. So let's see if we have here 1 over a very big number, so maybe like a million, 1 over a million. We get a very small number. Here, let me do 1 over a billion. Oh my goodness, 1 over, I want you guys to actually see this. Okay, well anyways, this is, if you guys recall, scientific notation, this right here would be 0.000000001. So this is a very, very small number, very, very small number. So this number actually goes to 0. It's a very, very small number that we get as a result. It goes towards 0. Let's look at negative side. So what about 1 over a negative very large number, a negative large number. Well, we get something, again, very, very small. It's going to be negatively small, but it's still going to be about 0. So 1 over negative. So it's going to be a small number going towards 0. So it's going to be going towards 0. So if we were to graph this, so this line, it says as we approach x from the left-hand side. So we're going to look, our x equals 0 is right here, and we're approaching from the left-hand side. So as we get closer and closer to 0, so we're going to, so it's pretty close to 0 over here. As we get closer to 0, it gets more negative. As we get closer to 0, even more negative. Closer to 0, even more negative. Closer to 0, even more negative. So what happens here is there's actually a vertical asymptote right here. The closer we get to 0, the more negative it gets. Let's see what happens over here. It doesn't tell us anything that happens over here. It's just the end behavior. So let's see what happens over here. So as we get closer and closer, as we increase, so as this gets bigger and bigger, we have here, or as we get closer to 0 on the right-hand side, so on the right-hand side, so it might start somewhere right here. And as we get closer to 0, the numbers get increasingly large. As we get closer to 0, the number is going to get even larger. As we get closer to 0, the number is going to get even larger. Closer to 0, even larger. Closer to 0, even larger. So this one, there's also going to be another vertical asymptote. As we get closer to 0, the numbers get larger. Let's see what this tells us. So this tells us as we go towards infinity, so as x gets very, very big, it says that as x gets very, very big, the number, our y value goes towards 0. So as x gets very, very big, our y value, which was up here, gets very, very small. It goes towards this 0 value right here. So as x gets big, our y value is going to get small. So as x gets big, y gets small. So this one's going to go over here. This one says as x gets negatively large, so as we move left along the x-axis, it says that the result is going to be 0. Our y value goes towards 0. So as we go along this x-axis, our y value gets closer and closer. Our y value gets closer and closer to 0. So this is a sketch using this kind of end behavior stuff that we're going to be looking at with infinite limits and limits at infinity. So here, I didn't write it down. These are what we call limits at infinity. Limits at infinity. And this is when x goes to some positive or negative infinity value. So what this tells us right here, this one told us that as we got closer and closer to this 0, the numbers went from negative infinity to positive infinity. When this happens, this is where our vertical asymptote was. This one right here, this says as we got larger and larger, as our x got larger and larger, our y values got smaller and smaller. So this was this horizontal asymptote right here. So that's the basic idea. We're going to be looking at more examples like this, so stay tuned.